All right, here are our 5.1 notes, you guys. We're talking about polygons here. So as we mentioned before, we are working with shapes a lot in this next unit. So the first section here, 5.1, we are talking about polygon angle sum. So we're going to start, you guys, by sketching each of these shapes. So a triangle, hopefully we all remember what a triangle looks like, right? We've been working with triangles all semester at this point. Triangle has three sides. There is one triangle in a triangle. And so the sum of the interior angles of a triangle, we know, is 180 degrees. Okay, now quadrilateral has four sides. Quad means four. So we have four sides in a quadrilateral. And in a quadrilateral, we have, if we draw our diagonal, we see that we have two triangles, which means that the sum of our interior angles is going to be 2 times 180, because a triangle adds up to 180 degrees, and we have two of them. So sum of the interior angles of a quadrilateral is 360 degrees. A pentagon, maybe you guys remember what a pentagon is, maybe you don't. Pentagon has 5 sides. And a pentagon, if we draw a pentagon and draw in the diagonals from one of our sides, one of our vertices, we can see there that we have 3 triangles in a pentagon. So 3 times 180 is the sum of our interior angles of a pentagon. Hexagon has 6 sides. So we gotta go 1, 2, 3, 4, 5, 6. 6 sides. And if we have a hexagon and draw diagonals to each of our vertices from a single vertex, then we can see that we have 4 triangles in a hexagon. So the sum of our interior angles of a hexagon would be 4 times 180, which is 720. So do we see a pattern here, you guys? Right? With one triangle, we have 1 times 180, 2 times 180. So the more sides we get, however many sides we have. So on our hexagon, we had 6 sides, then we have 4 triangles. Pentagon has 5 sides, we have 3 triangles. Quadrilateral has 4 sides, we have 2 triangles. So we can see that the relationship between the number of sides and the number of triangles is that however many sides there are 2 less triangles. So if we have n number of sides, where n represents any number, it could be 12, it could be 15, it could be 154, right? However many sides there will be 2 less triangles in it. And then to figure out the sum of our interior angles, we're going to take however many triangles there are, which would be n minus 2, and we're going to multiply that by 180, the sum of one triangle. So this formula here is the equation for the sum of the interior angles of any polygon. Poly means many-sided, right? Polygon means that it has many sides. So the sum of any interior angles of any number polygon would be n minus 2. So we can use this to figure out if we have a 30-sided polygon, we got 30 minus 2 and multiply that by 180 to figure out the sum of its interior angles. Now, the sum of the exterior angles of a polygon will always be 360. No matter how many sides it has, the sum of the exterior angles of a polygon, exterior again means outside, right, will always be 360. Now we also have things called regular polygons, you guys. Regular polygons have all congruent sides and angles. All congruent sides and angles. So like a square is always a regular polygon because it has 4 congruent sides and 4 congruent angles. So whenever we have a regular polygon, the sum of the interior angles will still be n minus 2 times 180, but then what we can do So it'll still be the same. The sum of the exterior angles will still be the same. But then what we can do is we can find one interior angle. So if we have a regular polygon, where we know that all the sides and angles are congruent, then we can find the measure of one interior angle would be n minus 2 times 180 divided by n. So if there are 6 sides in our regular polygon, if we have a regular hexagon, then we would go 6 minus 2 times 180 and then divide that by 6, and that will give us the measure of one of our interior angles. And similarly, right, if we have a regular polygon and we want to find the measure of one exterior angle, it is so nice to have my laptop back, you guys. Then we're going to go 360 divided by however many sides there are. So those two formulas, we're going to see some problem types like that in this unit. Okay, so let's look at some problems here. So find the sum of the interior angles of a 15-gon. So they're saying we have 15 sides, we want to find the sum of the interior angles. Well, we know that the formula for finding the sum of the interior, we wrote it up above to be n minus 2 times 180. N represents the number of sides. So we're going to take 15 and we're going to plug it in for n. So that is 15 minus 2 times 180, or 13 times 180, which should be 2,340 degrees. So if you had a 15-sided figure, then the sum of the interior angles would be 2,340. Okay, we'll have some problems like that. We're just asking you to figure out the sum of the interior angles. We'll have some problems like this where we are missing one of the angles in our figure. Now we know this is a quadrilateral. It has 1, 2, 3, 4 sides and 4 angles. So we know that a quadrilateral, if we look up above, right, quadrilateral always adds up to 360 degrees. The interior inside angles of a quadrilateral add up to 360 degrees. So all 4 of those angles here must add up to 360. So if we do 79 plus 110 plus 55 plus x, we need to get 360. So then we can combine like terms and subtract 244, and we get that x needs to be 116 in order for that to be 360 altogether. So we'll have some problem types where we're trying to find the missing angle. We'll have some problem types where, like this one, okay, so again, regular hexagon. So we're going to use those 2 regular formulas that we had, the measure of each exterior angle of a regular hexagon. So we're looking for one angle here, not all of them. We're looking for the measure of one angle. So we're going to go 360, which is the measure of all exterior angles always, and we're going to divide it by how many sides there are, which in this case, because we have a hexagon, is 6. So we get that the measure of the exterior angle equals 60 degrees. And then this one is using that same idea. We have a regular polygon, but now they give us the measure of one of the exterior angles, and they want us to figure out how many sides there are. So we'll have some problems where we're trying to figure out the measures of the angles. We'll have some where we're trying to figure out how many sides there are. So we're still going to use our 360 divided by n equation, because that is the equation for finding the measure of an exterior angle of a regular polygon. But in this case, we know that exterior angle equals 12. So that means we have 12 equals 360 divided by n. Okay, we need to get the n out of the fraction, so we're going to multiply both sides by n. That's going to give us 360 on this side because the ends cancel out. And then we have 12n on the other side. And then we can divide by 12. So we get that n equals 30. So there are 30 sides on this polygon. A 30-sided figure would have a 12-degree, a 30-sided regular polygon would have a 12-degree exterior angle. Okay, so let's practice with some of those problem types. So I'll do some and then I'll ask you to do some too, okay? So what is the measure of each interior angle of a regular 18gon? Okay, so that's where we're going to use that regular formula up above, n minus 2 times 180. That would be the sum of all of our measures. And then we're going to divide that by how many there are. So we're going to plug 18 in for n. 18 minus 2 times 180 divided by 18. Okay, that is 16 times 180. 16 times 180 is 2880. So we have 16 times 180 over 18. 16 times 180 is 2,880, and we're going to divide that by 18, and we get that the measure of one interior angle of an 18-sided figure is 160 degrees. The sum of them would be this 2,880. The measure of one of them would be 160. Okay, next one, we're trying to find our missing angle here. We have 1, 2, 3, 4, 5 sides. So our sum, on the one before, well, we already know our pentagon sum, but if we didn't, okay, we could find the sum of our angles, which is 5 minus 2 times 180, n minus 2 times 180. That is 3 times 180, or 540. So 540 is what they all have to add up to. And then we're going to go 540 must equal x plus 92 plus 135 plus 105 plus 87. Combining like terms, we have x equals, or x plus 419 equals 540. And then when we subtract 419, we get that the measure of x then must be 121. So that it completes this pentagon. Okay, so next one we gotta figure out how many sides there are here. We can count the angles, 1, 2, 3, 4, 5, 6, 7. So this is a 7-sided figure. So if we want to solve for x, we need to know what the whole thing must add up to. Okay, the whole thing must add up to 5 times 180, which is 900. So all of these angles must add up to 900 total. Okay, we know that this box is 90. So we're going to go 500 equals 142 plus 150 plus 90 plus 148, 140, 136, and x. And we combine like terms, we get 798. Oh, sorry, this is supposed to be 900, not 500. 798 plus x equals 900. And then when we subtract 798 from both sides, we get x equals 102. Okay, so I'm going to put this one as a problem on your, attached to your notes in Delta Math. So you can do that problem in Delta Math. Okay, show your work here and then input your answer. So again, same as we did the problem before. And then last two problems here. If the exterior angle of a regular polygon measures 40 degrees, how many sides does the polygon have? So this is like the one we did above. 40 is the measure of our regular polygon, and we know that with a regular polygon, we can find the measure of one exterior angle by doing 360 divided by n. So as we did before, I'm going to get n out of my denominator. So I'm going to have 40n equals, my n's here cancel out, so it equals 360. And then I divide by 40, and I get that n equals 9. So n, a regular polygon that has 9 sides, would have a 40-degree exterior angle. And then last problem type here, kind of like the one we did before, but this one we're using an interior angle. So the interior angle of a regular polygon, now there's two ways to approach this problem, okay? I'm going to show you here the harder way. Well, not necessarily harder, but I'll show you one way and then we'll do the other way in class. So we know, okay, that the interior angle here is 108 degrees. How many sides does the polygon have? Okay, so we know with a regular polygon, the interior angle we can find by doing n minus 2 times 180 divided by n, right? Okay, now we need to solve for n. So we got to get it out of our denominator first. So I'm going to multiply both sides. That gives me 108n equals, here these n's cancel out, and I have 180. I'm also going to go ahead and distribute that. So I have 180n minus 360. Then I'm going to get my n's on the same side. So if I subtract 180n from both sides, then I get 72n equals negative 360, or negative 772. And then I divide by negative 72, and I get that n equals 5. So we know that this is a 5-sided figure. And actually, I'm just going to go ahead and show you the other type right now, so you can choose which version you want to do. Okay, honestly, so this one's a little tricky for me. So I like the other way better, okay? So here's the other way, is an interior angle, interior plus an exterior angle, will always add up to 180 because they will always be a linear pair, okay? So with that knowledge, interior plus exterior will always be 180. I can find, so if I know my interior angle here is 108, then 108 plus my exterior angle must equal 180. So that means that one exterior angle of this figure would be 72, right? And then to find how many sides there are, I know that 360 divided by n needs to be 72. So really, you guys, the shortcut here, we're multiplying by n dividing by 72. We're really just switching these spots, okay? Multiply by n. I'll write it out here. Sorry. Multiply by n. That's going to give me 360 equals 72n. And then divide by 72. So I get n equals 5. So same answer, different ways to approach it. I like this way better because I think that there's less work right here than over here, okay? Sometimes the more we're doing, the more room there is to mess up, right? So it might be nicer to get in the habit of doing the second version, okay? Unless you feel really good about that first version, then go for it. More power to you. But the second version, if we take that interior angle and subtract it from 180, that'll give us the exterior angle. And then we just have to do 360 divided by that exterior angle to give us how many sides there are. Okay, so there's our first set of notes, you guys. 5.1, talking about the measures of angles in polygons. And we got some formulas up here at the top that are going to be very important to remember.